Welcome, boys. This is going to be the first video that I've proactively recorded this winter by actually exiting the house. Everything else you've been watching, of course, has been pre-recorded because your boy here has been sitting inside playing video games and watching movies all winter. It's been a pretty nice time. But, as you can see on the ground here, we've had some snow. You may noticed in a previous video where I did a long drive in the Crown Vic in the snow. The roads have been treated with salt and plowed, and as you can look at the side of the car there on the decals and the doors, you notice it's covered in it. So in this video, we're going to do a little bit of a mishmash of topics. We're going to combine a chemistry lesson with an unboxing, a product review, and demonstration on the Crown Vic, the pressure washer from Harbor Freight, and the new attachment I just got that we're going to unbox here in a second, which is from Amazon, and it is an undercarriage pressure washer attachment. So let's hop on inside and unbox that thing.
This is what just came in the mail today from Amazon. Yes, we're combining chemistry, unboxing, and Crown Vics all in one go. And cats! We have two quick disconnect pipes here. One with a bend, one that is straight. And this dude. Here, kitty, would you like to play inside this box? I bet you would. So, it's got wheels and it's got jet nozzles. This thing, bought on Amazon, works for any pressure washer that is at least 1500 psi. So, I don't think we really need instructions on this, but here they are. It's going to be as simple, yeah, she did get in the box, as connecting these two dudes together, attaching it to this, and then to my pressure washer, so I can wheel this thing under the car and clean the underneath of it. So that's what you're going to see next.
This is the pressure washer we're using from Harbor Freight. I've done a previous video on this, but just showing you exactly what we're using. And this is what we purchased from Amazon, the attachment for the undercarriage cleaner. So let's put it up. Okay, and first part is the washing. So I'm going to voice over this while we're doing this. Now, normally when you wash a car, you always want to start from the top and work your way down, because that's the easiest, most efficient way of doing it without redoing work and doing too much work. Now in this case, because the car is covered in salt and it isn't just dirty, I'm actually going to pressure wash the underneath of it with the attachment first, and then while that's dripping and soaking and doing its thing, I'll go ahead and wash the actual top of the car, the body panels, and then we're going to redo the undercarriage and finish up with that. But I figured I'd go ahead and pretext that before we go into our chemistry lesson now. And you may be asking, what is the point of all this? Why do we need to wash salt off a car? What's the big deal? Well, to put it plainly in simple terms, cars are made of steel. Steel rusts. Rust is bad. Salt accelerates that process. So, what are cars made of? They're made of steel. What is steel, you might ask? Well, steel is an alloy of iron and carbon. That alloy, only 2% of it is carbon. The rest, of course, is iron. Iron is, of course, an element on the periodic table. It's known as a ferrous metal. And what is rust? Well, rust is an oxidation reaction. The iron reacts with water and oxygen to form hydrated iron oxide. That is what you see as rust. The iron and steel rust when they come in contact with water and oxygen. Both are needed for rusting to occur. So why do cars rust? So rust only requires an anode, a cathode, and electrolyte to form. The metal in your car supplies the anode and cathode, which are positive and negatively charged particles respectively, while water is the electrolyte. So salt is much more effective at carrying electrons than water with a low salt content. Salt water is more effective at carrying electrons than water with a low salt content. So what is water? Well, simply put, it is hydrogen bonded to oxygen, which we know as H2O, two hydrogen molecules bonded to an oxygen molecule. What is salt? So chemically, salt consists of two elements, sodium and chloride. You'll also remember them from the periodic table of elements, sodium being Na, chloride being Cl. So neither of these elements occur separately and free in nature. They are found bond together as the compound sodium chloride. So why does sodium bond with chlorine? Sodium atom transfers one electron to the chlorine atom so that they both have full outer shells. Because the sodium ion has a positive charge and the chlorine ion has a negative charge, they are attracted to each other and form an ionic bond. What is an ion, you ask? An atom or molecule with a net electric charge due to the loss or gain of one or more electrons. And remember, earlier we said hydrogen and oxygen bond together in water to make water. So is water an ion? Well, water is ionic in nature, but the bond is called covalent, with two hydrogen atoms both situating themselves with their positive charge on one side of the oxygen atom. Oxygen atom, of course, has the negative charge. That is how they bond together. And you'll note when you change coolant and things like that in your car, they always say to use deionized water or distilled water. So distilled water does not conduct electricity on its own because it is deionized. It is a subsection of deionized water, which means it doesn't have any of those minerals in it. So with that said, theoretically, if you took an electronic device and submerged it in pure distilled deionized water, your electronic device would operate normally. It would not short out or anything like that because the water cannot conduct electricity on its own. You need the ionic properties of the minerals in order to conduct the electricity, causing the short and damaging your electronics. So, since we know that salt is thus bad for cars, you might be asking, why do we even put it on the roads then? What's the point? What does the salt do? So, salt prevents the water molecules from solidifying into ice crystals at 32 degrees Fahrenheit. Instead, it stays slushy at that temperature. It will eventually freeze at around 15 degrees Fahrenheit. And in comparison, salt water, like the ocean, that will freeze, but at a much lower temperature than our 32 degrees fresh water. The salt water in the ocean freezes at roughly 28.4 degrees Fahrenheit, and that is because of the salt in it. So how do we clean the salt off the car? So osmosis is known as the movement of water across a membrane. So salt triggers osmosis by attracting the water and causing it to move forward, normally across a membrane like in your body, but on these cars they don't actually have membranes. But what is going to happen is the salt is a solute. So when you add water to your salty car, it is going to diffuse, spread out the concentration of salt, and creating a salt water solution. So in other words, the pressure of the water itself is going to act as a solvent and a cleaner and remove stuck-on dirt and salt. And the salt that stays attached to the car temporarily is going to cause the salt to diffuse and absorb into that water, reducing its concentration, and then as gravity pulls the water off or evaporates, it'll fall, removing itself from the car until you strike it with more water, which is why I wash the undercarriage first, so that way I can hit it with high pressure water, remove some salt. What doesn't come off will be absorbed into the water. It'll drip from gravity back onto the ground and clean itself. And because I'm not 100% convinced that one small little treatment of undercarriage wash will remove all that salt, I go ahead and do it once, and while it's using osmosis and diffusion, that salt that remains on the undercarriage will just kind of fall while I'm cleaning the rest of the car. But then once we get the rest of the car nice and soapy watered and scrubbed clean, I'll go back and hit the underneath one last time with the pressure washer undercarriage attachment. You do want to make sure while you're cleaning the salt off your car, you pay really close attention to everywhere that the salt and slush get flung onto from your wheels. So the inside of the wheels, your braking and suspension systems, the inside, the wheel wells, under them, the front, the back, and the bumper covers. So you'll note I'm spending a lot of time in the wheel well area because that's where the large concentration of that salty, slushy water and ice is going to be. If you don't park your car out in the sun for it to melt and drop all that salt off, you've got a bunch of slushy, compacted salt just sitting up in your wheel wells, near your tire, up against your body panels, and that is holding moisture. So because it's much colder out and it's not melting, that moisture is just sitting there. It's getting stuck and it's staying there. And what you don't want to is to accelerate the rust process, because all it takes is for iron to be exposed to your oxygen and water naturally to start rusting. The salt only accelerates that process. So you want to get your salt off the car as quickly as reasonably possible. If you see excess chunks of the salt on there, kick them or pull them off, and then pressure wash any loose salt that may be hiding in crevices.
Okay, boys, and before we give it the last undercarriage wash, you just need to pay special attention to these areas in your car, whether it be a Crown Vic or not, because as the wheel spins, it's going to sling up a bunch of icy snow and slush up in these wheel wells. So you'll see some people driving around, they just have nothing but ice caked up in here, and they park and leave it like that. I always make it a habit to kind of kick my mud flaps to let all that fall, and then if it's not too cold or I'm not worried about getting too dirty, I'll kind of make some of that stuff fall out of there. That way it's not stuck up in there, holding salt and trapping moisture up against your body panels. And ditto for the back. On both sides, I noticed there was a bunch of ice, even though I still kick the mud flap. Kind of back in here, and actually still you can even see there's just a little bit of ice sitting up in here. So you just want to kind of make sure you get all that out of there. And that's it. Just sitting on the exhaust. You just want to make sure you got as much of it out around here as you can. This is another spot where it likes to collect. You just want to get that out of there. So, alright, now that we've succeeded in that, I'll go ahead and do the last undercarriage clean, and then we are boom done, boys.
So overall, I'm actually pretty happy with this product because it's going to eventually pay for itself. If only in the form of, normally to get to your undercarriage wash in these automatic car washes around here, you have to pony up the dough and pay extra for that service. Plus, you're not really getting your money's worth from it. It's lasts a whopping 10 seconds at the most. It stays in a fixed position as you drive your car over it. Whereas with this thing, you can spend as much time as you want in one area or multiple areas. You can go in from the side, the front, the back, the other side. You can get it in at different angles to really get in there and clean that undercarriage. And that in of itself, I believe, is worth the price that you're paying. Plus, you don't have to leave the house or anything to use it. You can just use it in your own driveway. And as the old saying goes, an ounce of prevention is worth a pound of cure. So by removing the salt before you start rusting, you're saving yourself the time and expense of having to do body work or weld in pieces of frame or anything like that. So from a cost perspective of just cleaning it, it's worth it. Ditto for it being a maintenance/preventative measure.
Alright, boys, and I believe that's going to conclude our little chemistry lesson slash car washing slash unboxing slash product review of this Amazon Undercarriage pressure washer. Thanks for watching, boys. Peace.